Twin primes are prime numbers that are separated by 2. For example, the pair 31 and 29 are separated by 2 and hence they are called a twin prime pair. Likewise, cousin primes are prime pairs that are separated by 4. For example, 71 and 67 are separated by 4. Sexy primes are prime numbers separated by 6. So 41 and 47 are separated by 6 and hence they are a sexy prime pair. We would like to generate these pairs using ZCubes. At the same time, trying to see if we can make it possible to generate the pairs of primes separated by any particular number. So let's start with first understanding the code, and we can select any code in the coding area and press Control while we are pressing run, and it will execute just that much of code. So here, these are the prime numbers till 100, and we can apply a math function on this, which means that it will apply for each element in that array, primes 100, a function, and the function takes 3 parameters: the element itself, its index, and the data array itself. So here we would print out the index, the element, and this one is interesting because here we are finding out all the prime numbers till that number. So for example, if you take the index 2, which contains the prime number 5, 2 and 3 are all the primes before that. And the next column here indicates the difference between the prime number and all its previous primes. And notice the use of the bar minus bar operator. So it's a matrix subtraction of the matrix on the left and matrix on the right. If it is not a matrix on the left, it converts it into a matrix and does the subtraction. Now with this, we see that for each element in the array, like 2, 3, 5, 7, 11, so forth, it has given us the index, the previous sets of prime numbers before that, and the differences between the prime number and all its previous prime numbers. For example, for 11 and its previous prime numbers are 2, 3, 5, 7, and it finds the difference between 11 and 2, which is 9, 11 and 3, which is 8, 11 and 5, which is 6, and 11 and 4, which is 7. So with this structure, we can now look at how to find let's say cousin primes which has a gap of 4. So we declare a variable with gap as 4, and we can run a filter function on this array, which basically would find the difference between the primes, which are these sets of numbers here, and see if that gap is included in that list. So here, for example, for the prime number 11, the differences between 11 and the previous primes are 9, 8, 6, and 4. So it has 4 in it. So obviously it's a cousin prime. Likewise, 3. For the third element, 7, the prime number 7, the differences between the prior prime numbers are 5, 4, and 2. So obviously that's also a cousin prime. Whereas prime number 5 is not a cousin prime because the differences between 5 and all the previous numbers do not include 4. So with this filter, we can now get all the cousin prime numbers. So because these are cousin prime numbers, we can apply the array function, essentially saying if x is the value, give us x minus gap as well as x, so that we can now get all the pairs of such cousin primes. So 3, 7, 7, 11, and so forth, which is what we see here. Now we can convert this into a generic function. So here we have written a generic function, essentially the same code, but we have made it even more generic in the sense that we could say give us the primes with a certain gap until this number. So we have set by default the till value is 100, and the same code as we saw before, we filter the prime numbers until that number, and it checks if that gap is included in that list of differences, and if it is, it cranks out the prime number and the number that was before the gap, and it returns the result of this filtering in the array. But we have done a transpose and putting it to another array just for formatting reasons. You could have just returned it RET itself. Now let's run this function for a set of values. Now what we have done here is we've said 2.10.2. That means give us the prime numbers, the cousin prime, the twin pair primes and the cousin primes and the sexy primes and so forth. So 2, 4, 6, 8, 10 for all the prime numbers till 100. So when we run this, the system gives us for gap 2, it gives us the prime pairs, the twin primes as the first result, and cousin primes here, and the sexy primes here, and the primes with differences of 8, differences of 10, and so forth. So you get the whole collection. Now we can just simply change from 100 to 1000 to find what are the sets of primes for up to 1000. So here it says all the twin primes till 1000, all the cousin primes till 1000, and all the sexy primes till 1000, and 8, 9, 10, and so forth. Remember, you could have just simply also done, let's reduce it to 100 just for sake of doing it faster. Up till 30, find all the combinations of that in a simple manner. So these are for gaps from 2 to 30 in even spaces, like separated by 2. All the primes till 100, it finds the prime numbers that have such a gap. So for 2, for gap 6, for gap 8, for gap 10, 12, 14, 16, 18, 20, and so on. So if you take any pair of primes here, 41 and 13, the difference will be 28. And likewise here, 61 and 31, there is a difference of 30. So it shows how we can simply through the notations run functions on matrices and combinations of numbers to get very interesting results. Now we can assign this result to, let's say, RES, and then this the third element in it will have the the 311 and so forth. So 311 is going to be, let's say, 2, 4, 6, 8. So these are separated by 8. So this is the way we can create functions and run them over loops on a series of values in an array and do pretty complicated operations on it. Thank you.